Hello everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the technical session 9A. Myself, Shashwat Mani Tripathi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communication, SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held yesterday, which is 19 January 2026 in Pune, India. And the virtual event is being held through Zoom from 19 to 21st January 2026. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answer. On 9 minutes, I will raise a very gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write it to me in a chat box. Just before we start the session, I would like to introduce to the chair of this session, Dr. Rashmi Kale. Ma'am, Ma'am is an associate professor in the electrical engineering domain at Vishwakarma Institute of Technology, VIT, Pune, India. Her academic and research interests include power electronics and power system, actively involved in teaching, research, and technical publication. Dr. Khale contributes to academic excellence and innovation in electrical engineering education at VIT. Ma'am, would you like to share a quick opening remark with us?
Hello, hi. Good afternoon, everyone. It's been nice to be a session chair for this esteemed event, and I really hope that all the presentations will be up to the mark and we will learn something from it. So, all the best participants and give your best, and it will be a really a good sharing knowledge with each other. So, hope everything is gonna go smooth. So all the best participants and you can start your
Okay, ma'am.
presentations.
Okay. So first we have Bhavana, paper title, A Study of Possible AI Applications Within Childhood Educations. Bhavana, are you there? So next we have Priya, paper titled Digital Tool for Educational Governance, Primary School Administration in Uttarakhand.
Hello, good afternoon. Am I
Good.
audible?
Yes, you are audible. Please present your screen and start the presentation.
Okay, just wait. So my PPT is visible.
Yes, it is.
Yes, ma'am.
Okay. So good afternoon, one and all present here, respected chair and fellow participants. I am Priya Chanana, and today I will be presenting my title paper, Digital Tools for Education Governance, Primary School Administration in Uttarakhand. My presentation focuses on how digital governance tools have influenced primary school administration, particularly in the Garhwal region of Uttarakhand, especially during and after the COVID-19 pandemic. So I start with the introduction. So, education, as we know, is a foundation pillar for human development, economic growth, and the social justice. The effectiveness of the education largely depends upon how well it is governed. By the rapid growth of the technological advancement, e governance has emerged as an important mechanism to improve transparency, efficiency, and accountability in the education sector. In India, we introduce a different kinds of e-tools for the education purposes, such as Diksha, Swayam, and Shala Darpan. They have significantly changed both the administrative as well as the academic aspects, especially in the rural areas of the Uttarakhand. As Uttarakhand is a hilly area and geographically fragmented state, so it faced a lot of challenges such as poor connectivity, lack of infrastructure, and limited digital skills among teachers and the parents. These challenges restrict the full potential of digital governance, despite we having the policy of National Education Policy 2020, which supported with strong emphasis on digital inclusions. So, this objective of the study is first to examine the implementation and the effectiveness of e-governance initiative in primary education in Uttarakhand. Secondly, to evaluate the impact of digital tools on administrative efficiency, transparency, and accountability in school management. Thirdly, to identify the challenges faced by teachers, administrators, and parents in adopting digital governance. And the last one is to suggest certain strategies for its strengthening the digital governance, ensuring equitable access across rural and urban region. After that, I collected the data, and data analysis has to be a quantitative data, which is especially focused on the Garhwal region, that covering the multiple districts in the Garhwal, and it focused on primary school stakeholder, their experiences during the COVID-19 and the current period. The data analysis has to be segregated in three major dimensions. Number one is the digital infrastructure, after that government policy responses, and the teacher and student readiness. So first of all is regarding the digital infrastructure. So under the digital infrastructure, we covered the different districts in the Uttarakhand region, and that has to be covered as a data shown in the PPT, like the reliability of internet access during the online learning. After that, the accessibility of devices such as smartphone, laptops, and the tablets, then availability of electricity for the uninterrupted learning, and then the affordability of internet, data, and broadband services. So the finding from these all data collection is the internet connectivity and the electricity supply were highly inconsistent, especially in the remote areas, whilst smartphones were more accessible. Their shared usage within the families limited effective learning. So high data costs further widen the digital divide between the rural and the urban student. After that, this basically based on the government policy responses. So under the government policy responses has to be segregated in the different kinds of the questions, like the provisions of digital learning resources and the financial assistance and the scholarship that has to be support the education system during that period. Although the analysis from these two slides is that although the government introduced platform like Diksha and online content, their reach and effectiveness varied across the districts. Financial support helped some families, but it was insufficient to ensure universal digital access, especially in the marginalized community. The next slide is based on the teacher, how teacher and student has to be ready for such condition. So this also segregated for n number of questions, uh, like student confidence is using the digital uh, like student is confidence for using the digital platform and the online during pandemic, and after that, how teachers are prepared for conducting the online classes during the pandemic, and what is the availability of training and guidance on using the digital tools, and how much difficulty they have to be faced during the adaptation of the new education through the online process. So, as per this, the conclusion that the study found that many students lack confidence in using the digital platform. Teacher also face a difficulty due to the limited training in the digital pedagogy. Although some training initiative were exist, but they are for a short term, or we can say they are inadequate. So, as per the analysis, it's mentioned that the teachers and students experience a stress, or we can say adaptation of challenges because of lack of training, or we can say the lack of resources or infrastructure we have. Now, the next slide is related to the challenges and the issues. So, the first one issue is like the digital device. So that digital divide is a persistent gap between the rural and the urban area in terms of the access of internet connectivity, or we can say the digital devices and the electricity. So many students in the remote area, they depend upon the sharing of data through the smartphone, but they face a lot of network disruptions and some kind of we can say financial issues also, and the infrastructure issues also. Next one is the inadequate teacher preparedness. So while teacher were shifted from quickly from offline to the online platform, so they are lacking their prior training to how to use digital tools and how to basically inculcate themselves in the online pedagogy. And the next one is the weak administration or monitoring system. Although we have the digital tools, we have the digital platforms we introduced during that period, but there is lack of supervision, there is lack of data verification, and there is no follow up for the mechanism at schools and block levels. So there is a chance of the poor administration and a monitoring challenge. After that, the next one is the poor digital infrastructure. So this is the main issue that disrupt the education because there is unreliable internet connectivity, power shortage, lack of technical support, and it made a lot of difficulty for the school to basically consisting the digital governance tools. After that, there is a limited parental awareness and digital literacy. So many of these students, they are belongs to the rural and the marginalized group, so they're unable to support their children because they are not familiar with such kind of a digital platforms, or we can say the low income exposure. The next one is a psychological stress among teachers as well as the student. So as we compare this with the international perspective, so they introduce the mental well-being kind of a lectures in their education system, but in India we don't stress on that. So the transition from offline to online, that create academic pressure as well as that create isolation, creativity like anxiety, and they may enhance the such kind of a difficulty to the student to learn something. So these all are the challenges and issues. Then we come to the strategies. Strategies, we can say how we can uplift or overcome from that situation. So we need certain kind of a future benefit strategies. So number one is the policy maker and the government authority. So there is a need for the government and the policy maker to invest to sustain certain resources for the digital infrastructure, and they must certain policy as regard to the region specific policies. After that, the education institute has to be strengthened. There should be a monitoring procedure, so continue monitoring and to update their digital devices. After that, teacher must go for a practical training in digital pedagogy, and then parent and guardian also included for the digital literacy and the awareness program. And there is a need of technical provider and the ed tech firm. So there is a need for the playing of both the technology in the sense that ngos has to basically pay something or to contribute to the society regarding the technological things, and the same way low cost technology solution has to be there, and we have to launch certain kind of uh, e tools, so it will be help to the student to learn something, then come to the conclusion. So this study concludes that digital tools have significant improved administrative efficiency and transparency in the primary education at Uttarakhand. However, the gaps which is related to the infrastructure gap, digital illiteracy, and uneven implementation of resources in the full potential way. The finding confirmed that the excess of digital infrastructure and the teacher readiness are the most influential factor in the successful of the e-governance. The COVID-19 crisis, or we can say any kind of a contingency happen in the future. So they may be devastating or creating an opportunity to re-evaluate the right to education in the digital context. While we have the strong national education policy, which basically framework, and they have the implementation with with the view to aligned with the realities of region like Garhwal, and the right to education should be viewed in the living and the evolving right, requiring continuous policy support and the strong infrastructure, as well as there is a need for the community participation. Thank you. If any kind of questions or anything, so you can ask, or any
Thank
kind
you
of a
for
suggestion.
thank you for the presentation. Ma'am, do you have any questions?
Yeah, actually, you have suggested some policies over there, but already many policies has been implemented, and though it is an online platform, so actually students in offline platform are very tough to taught because they won't concentrate much. So how do you think that online learning will give the benefit in regard to that?
So, ma'am, the benefit is regarding that because it is not about the current situation also, but we're talking about the any kind of a future contingency. Like previously, we suffered from the COVID-19, so we have seen that the education system is totally shut down. So we need a certain kind of a provision so we can add on that the student can relate with the hybrid mode. Matlab we have to make them comfortable with both offline as well as the online mode. So that's why in the rural area, especially, I talk about the primary education, which we provide free and compulsory. So the government has to initiate certain kind of a tool to basically implement properly the education to those children, those basically belongs to marginalized group. That means they don't have a resources, they don't have such money. So this kind of a thing has to be there. So we can say yes, we can achieve the goal of the universal education in all the levels. So,
Have you think so about the problems that internet connectivity in the rural areas and the power cut nowadays that is happening in many of the villages? There is 10 hours of power cut is still there. So what
hmm.
will be the solution? Are you trying to provide it for it?
So, ma'am, there is actually, they all are under the control of the government, we can say, like the electricity and all, but the research is based on the Uttarakhand region. So, in the Uttarakhand, there are many hilly areas. There are some schools that not basically operated properly, even in a physical mode also. So, there is a basically a kind of a channel upon the government to channelize and to check and to monitor whether they efficiently basically what I can say, efficiently use the right to education in a proper sense and the same way in a digital context. Because when we talk about the right to education, the right to education has to be not only in a physical mode, that has to be in a digital mode also. So government has to ensure they have to provide certain kind of a tools. So that is all about the government. So such kind of a suggestion, like only that the government need to intervene, or we can say invest in such kind of a thing. I think the state government has to introduce certain kind of a thing as per their region based.
Participants, any other question from your side? Yeah, that's it from my side.
Okay. Thank you, ma'am. Thank you for your valuable questions and suggestions. Thank you.
So next we have Margin and Cola, paper titled Fontify AI, a font exploration and recognition platform with a deep learning.
Hello.
You may please present your screen and start the presentation.
Oh, is my screen is visible?
Yes, it is.
Okay. Good afternoon to everyone. My name is Margin Ankola, and today I will be presenting our research paper titled Fontify AI, a font exploration and recognition platform with deep learning. This work is co-authored by Nishat Saik, and we are presenting here at SMARTCOM 2026. In this presentation, I will be briefly discuss the motivation behind our work, the system architecture, the deep learning methodology we adopted, and the result we have achieved. Here is the quick outline of my presentation. I will start from an introduction and motivation to result and conclusion. Typography plays a critical role in digital design, branding, and all over user experience. With the rapid growth in digital platforms, thousands of fonts are now available to designers and developers. However, identifying fonts from images and navigating large font libraries remain challenging due to high visual similarity between typefaces and lack of unified exploration and recognition system. To address this gap, we have proposed a Fontify AI, an intelligent platform that combines interactive font exploration with AI-driven font recognition system in single system. The motivation of work comes from real-world design workflows. Designers frequently encounter font images or online content without knowing the exact font family, which slows down creative process. Existing tools are fragmented, typically supporting either exploration or recognition, but not both. Font recognition itself challenging due to high interclass similarity, variable image quality, background noises, and need of real-time interface in scale. The objective based on a motivation to develop a unified platform that combines large-scale font exploration with AI-based font recognition to design and train deep learning model capable of accurately identify font families from text and images. To leverage transfer learning using ResNet 50 to learn fine-grained typographic feature across the nearby 2000 font families and to achieve real-time performance while maintaining high accuracy and usability. We reviewed existing research in font classification, syntax analysis, and multi-font recognition. Prior studies show that CNN-based model performs well in visual text tasks. However, most approaches are limited in scale, focus on character level recognition, or lack of real-time deployment. These gaps directly motivated us to design our unified and scalable system. From existing approaches, several key limitations were identified. Many fonts share nearly identical visual characteristics, making difficult to identify. Variations in images quality reduce recognition reliability. Scalability becomes challenging when managing thousands of font families. Achieving low latency, inference, and handling background noises remain open challenges. Quantify AI is designed as a web-based platform for fast, accurate, and accessible typography analysis. The system enables users to browse and search large font collection, filter font by attributes, preview fonts with custom text, and upload images for AI-based font recognition. Architecturally, the platform consists of a user interface layer, application layer, a dedicated AI service, and database. This layer design separates web application from AI, enables scalability and efficient performance. The font recognition engine is based on ResNet 50 convolutional neural network. Residual learning enables stable training across deep layers, making model suitable for handling higher interclass similarity among fonts. For model process images and predicts one of 1987 font families using ImageNet pre-trained weights. The model was trained over 180K synthetically generated font images, rendered using multiple text samples and font sizes. Training was performed using AWW optimizer with a cross entropy loss along with data augmentation and regularization. The system achieved top 1 accuracy of 72.82%, top 5 accuracy of 88.58%, and average inference time of approximately 87 milliseconds per images. This slide shows a real world font recognition example where when uh, when an image containing text in Kelly's Lab font was uploaded, the system correctly identified the font with a confidence of 99.97%. This result demonstrates the strong confidence separation and practical effectiveness. We have compared Fontify AI with existing approaches, and results are shown in here. To conclude, Fontify AI is a platform that unifies font exploration and recognition. By combining deep learning with a well-designed architecture, the system delivers accurate, responsive, and scalable font identification. Future work includes multilingual support, style-based similarity search, model optimization, and adaptive learning using user feedback. This slide lists the key research papers that supported our. With that, I would like to conclude my presentation. Thank you for your time and attention, and I will be happy to take any question.
Thank you for the presentation. Ma'am, do you have any questions?
Yes, I have. Basically, I wanted to know what is the use of your project?
The use of my project is basically for a developer and designer. As a designer, some designers see any fonts in any other websites on internet. They like that fonts, but they don't know the font family name of that font. They they love to take that font and use that in their website, but they don't know the font family. So for that, they will take a screenshot of that fonts, and they will upload that font in our website, and then they can get the font family name, and also they can download it from there.
Okay, I have one more question. Like you said, the font they like, they can get it, and the font family also. Like
Yes.
in our Puranas, Vedas, there are some Modi Lipi fonts are available. Can it convert the text that in Modi Lipi into the normal text, or only the font family it recognizes?
No, currently it just that shows a font family of English text words, not multilingual words. It's our future work because there is no many data sets for that. But I am finding it, and I can do it in future.
Okay, and how many languages fonts it recognizes?
Currently, it's only in English.
Oh, all right, that's it from my side. Any other
Thank you,
question
ma'am.
from the participants? Thank you.
Thank you, ma'am.
So next we have Kushagra, paper titled From Sound to Sight, a deep learning approach for attention-driven multi-modal fusion for violence detection in surveillance applications.
Is my screen visible?
Yes, it is visible.
Okay. Good afternoon, everyone. I am Kushagra Agarwal. I am from PS University, and I will be completing my graduation in 2026. So here I am to present a paper in front of you. From sound to sight, a deep learning approach for attention-driven multimodal fusion for violence detection in surveillance applications. So lately we have noticed that lot of crime rates have increased, and lot of crime rates have increased, and we thought of like when we were in college, we thought, why don't we use technology so that we can help to convert our society in some better way. So we thought of why don't we create a s- why don't since the usage of CCTV footages have been increased a lot, CCTV cameras have been installed to multiple places. We thought, why don't we use the CCTV footage to help police authorities or any concerned authorities to take care of the crime rates. So when we did a literature survey, we found that there have been models which were either a single, they were using single modality, either audio or just video data, or it also was like it wasn't even real time. We wanted something to create real time so that usually it happens that the police arrives at the crime location after the crime has taken place. So we thought of let's make it real time so that it actually impacts the society, and it's not just a research it's not just a research work. So when uh, when we went deep into it, we found that there has been made certain research on HLNet, which used to capture long and short range dependencies. So we thought, why don't we got inspired from the HLNet and we tried to create a multi-model framework for real-time violence and threat recognition using getting inspired from HLNet, which uh, and we thought of why don't we do multimodality, because detecting a violent activity or suspicious activity just by one modality such as an audio or a video wasn't sufficient proof enough to notify the concerned authorities to take actions. So we executed that, and we achieved a success rate of 92.38%. And even it's real time. So moving forward, I will explain the exact models and features that we use to make it happen. So most like uh, most of the surveillance system generate enormous amounts of audio visual data, but it 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 usually happens with the manual detection of violent incidents, or which are slow and error prone. That's why we came up with an idea to use YAMNet model for audio and X3D for video, which is integrated through an attention-based fusion mechanism, and it dynamically weighs both modalities, the system, and the system improves real-time violence detection even under noisy and occluded or incomplete conditions. So we are using a lightweight attention-based fusion network where audio-visual features are projected to a shared latent space and integrated using multi-head attention. It is robust even if one modality goes missing, and it is computationally efficient, and at the same time it is flexible. To achieve this remarkable achievement, we use the dataset XD Violence. It was a very vast data set. It has 4,754 untrimmed videos, which are almost uh, 217 hours long enough. Plus, it has a balanced data set such that it has 3,954 training videos, out of which 1,900 were violent and the other 2,000 were non-violent. So we came across this data set upon which multiple research work had already taken place, and they had also provided pre-computed feature vectors, namely I3D and VGG features. But again, if we used these feature vectors, uh, lately new modalities are happening, and even the feature extraction, we had to have our own feature extraction because we wanted to make things real time. So when we moved forward, we came across this proposed methodology in which We have an end-to-end multimodal system for violence and threat recognition in public safety environment using advanced machine learning and audio-visual analysis. So as I told, we are using YAMNet for audio and X3D for video. YAMNet has already been trained very well for meaningful acoustic cues such as gunshots, screams, and explosions, while X3D extracts spatio-temporal visual patterns related to violent actions like fights, crowd, panic, or weapon usage. So we are using a lightweight attention-based fusion mechanism that dynamically weighs the importance of each modality at every moment. This design ensures robustness in real-world conditions where one modality may be noisy, missing, or unreliable due to poor lighting, occlusions, or background noise. So this is our architecture diagram. We first begin with data acquisition for which to extract audio features we are using FMPEG. It's an Python library which helps us to extract audio data from a multimedia video, and we are using OpenCV to read video files frame by frame. Moving forward for pre-processing data in pre-processing layer, we are using YAMNet and XDD for pre-processing and feature extraction. YAMNet is used for audio and it is a TensorFlow library which helps us to convert waveforms to tensor format, and it gives us output as a in 1024 dimensions embedding for each segment, which is meaningful over time to yield a compact feature vector clip. Whereas X3D, we are using X3D for video, and it uses 16 frames per clip, which it resizes to a 224 into 224 pixels, and then we convert it from BGR to RGB, normalized before PyTorch tensors. So it is a PyTorch video library which helps us to output 2048 spatiotemporal embeddings. Moving forward in our processing layer, we have our deep learning models and multimodal fusion models. These help us in uh, like multimodal attention helps us to process multiple inputs together. So in one go we are having just the audio processing, in one go we are having just the video processing, and in one we also have audio video happening simultaneously, in one, so that we have a higher success rate and less false alarms are raised. And in our analysis layer, we have a sigmoid layer which outputs the probability from fusion classifier and applies fixed classification thresholds. So this is our attention fusion classifier. In this, during training, we have our attention fusion classifier, which linearly projects feature vectors to 512 dimensional latent space, combines them via multi-head attention modules with 4 heads, and classifies through a two-layer feed forward sigmoid output layer. We are using a loss function as binary cross entropy, and we are using Adam optimizer. For training, we have splitted the data set such that for training we have used 70% of the data set, and for validations and testing we have used 15-15 each. We trained for 40 POCs with a batch size of 64 samples. And over here our multi-head attention model takes care, and that's the best that we found out. Moving forward, we have a table in our next slide which compares our results with the other present remarkable research done. So we have compared our model on the performance metrics, including frame level, average precision, macro F1 score, precision, recall, Hamming loss, Jacquard score, exact match ratio, and mean average precision. These metrics collectively assess both classification, accuracy, and robustness across multiple categories of violent activities. Experiments were conducted on the challenging equity violence dataset, which contains diverse real-world violence scenarios with synchronized audio and video. The system integrates YAMNet for audio feature extraction and X3D for video representation, which are fused through a multi-head attention mechanism to dynamically balance the importance of each modality. And as I mentioned that we have reached a remarkable performance of 92.38%. Even our training and testing data shows that we have our model didn't get overfitted. So yeah, that's all from my side. I'm ready for any questions.
Thank you for the presentation. Ma'am, do you have any questions?
Yes, I do have a question. First of all, what will be the feasibility of your project? Because see, you said cameras, video, audios. So, like monitoring, if you are saying, in like suppose take an example of a Pune city, there are more than 1,000 cameras. CCTV cameras are working. Then how it is going to be work for real time purposes?
Like usually on the feed of these CCTV footages, we have manual laborers who are sitting there and monitoring the system. But if we install our software, it will automatically detect any violent activity happening so that it will draw the attention of the concerned authority. I mean, since as you told, there are thousands of CCTVs, it's not manually feasible for for a single person or a group of people to maintain that properly or to uh, take advantage of that properly. So, with the help of our system, it will ease their work and it will help the concerned authorities to decrease crime rates.
Okay. Have you checked your prototype in a real-time scenario?
We haven't deployed it in a real-time scenario, but we tried to upload certain videos which had certain violent activities, and we received our results in real time, like within 30 seconds, depending upon the length of the video.
Okay. And how much time does it take to train the model?
For training our model, it took very long. If I am not wrong, it took us about actually one of my teammate, he got credentials for AMD. Uh, so we had the 300 hours GPU instance over there. So we all the 300 hours GPU instance were used to training this model.
So see, the data set contains those videos. Again, we are going to feed it in those video. Again, it is going to be take the time, right? So, means how it is going to be worked in real-time scenario.
Like by to after our training was done completely, I downloaded certain videos which were not present in the data set, which were out of data set, and I used my manual camera to demonstrate certain violent activities such that so that I can test my model well. So we used those video clips rather than the ones which were present in the data set.
Okay, and in how much time it provides the result?
Within 30 seconds to 60 seconds.
Okay, all right. If this system works properly, it will be a beneficial for the society, I guess. So, thank you for your presentation, and it's really a good topic. Thank you.
Thank you, ma'am.
So next we have Prabhat Bojot, paper titled Genius AI SaaS, a unified multimodal content generation platform.
Hello.
You may please start presenting your screen.
Sure, sure. Just a second. You can see my screen, right?
Yes, yes.
Sure. I'll just start now. Good afternoon, everyone. I'm Prabjot Singh, and today I'll be presenting our work on Genius AI SaaS, which is a unified platform for multimodal content generation. This is a joint work with my colleagues Srishti Sharma from TCS and Arjun Pankajakshan from Ready Minds. So the current landscape of generative AI is highly fragmented. If you want to create a presentation with text, images, and background music, you need to use 3 or 4 different platforms and you need to switch context, explain the context all over from the start, manage different subscriptions, and deal with inconsistent interfaces. This creates inefficient workflows, especially for educators, content creators, and developers. So Genius AI solves this problem by bringing all these capabilities into a single unified platform, making AI-powered content creation accessible to everyone, regardless of their technical expertise. Recent years have seen tremendous progress in Gen AI across all the modalities. We have powerful language models, impressive image generators, and emerging video synthesis capabilities. However, these tools exist in isolation. Integrating them requires significant software development expertise, which creates a high barrier to entry for educators, artists, and content creators who could benefit most from these technologies. So our work, Genius AI, addresses this gap. Talking about the system architecture, Genius AI is built on a robust modern technology stack. The front end uses Next.js for server-side rendering and optimal performance, with Tailwind CSS for responsive design. Our backend leverages Next.js API routes for serverless architectures connected to a PostgreSQL database, which is managed through Prisma schema. And for security, we implemented the OAuth 2.0 authentication through Clerk with HTTPS encryption and input validation at every layer. So the platform follows a freemium model with Stripe integration for the premium features. Talking about the various content provider APIs that we have, the platform integrates state-of-the-art AI models through carefully orchestrated APIs. For text, code, and conversations, we use the OpenAI, which is the GPT models API. And for the music and video generation, we leverage the Replicate AI APIs. Now let me walk you through how the system works. When a user submits a prompt, it first goes through our Next.js API layer where authentication is verified through Clerk. The input is validated using TypeScript to prevent injection attacks. The request is then routed to the appropriate AI service, which could be either OpenAI or Replicate AI, based on the content type. Once the content is generated, the output is stored in our PostgreSQL database and rendered dynamically through the user prompt. And after that, the rendered output is shown on our platform. So security and privacy are the foundational uh, pillars for our platform. We implemented a multi-layered approach, starting with OAuth 2.0 authentication for user identity. And after that, all the data transmission uses HTTPS encryption. Every user input is validated and sanitized through TypeScript to prevent malicious attacks. Then the user data is isolated and securely stored in our PostgreSQL database with a compliance-ready architecture that respects privacy and data protection regulations for all the users that we have. Here's how the Genius AI dashboard looks. So, the dashboard is the central hub for all the content generation activities. The interface is designed with simplicity in mind. The user can see the remaining generations quota at a glance, which is supported in a freemium model. All the AI tools are accessible through this single page. The design is fully responsive, which works seamlessly across all the devices. And we have also integrated customer support through Crisp, allowing users to get help without leaving the platform. So this is how you log in to the platform, and this is powered by Clerk. You can either log in through Google or you can have your email ID and password. And this is how the landing page of Genius AI looks. Now, let me show you some real examples of content generation on Genius AI platforms. For example, this is the image generation. You can enter any prompt for generating the images. For example, in this image, you can see the prompt hybrid fruit of mango and strawberry. And additionally, you can also select the number of images that you want. For example, I've selected 4 images, and also the size, which is the dimension of the image. So here I have 5 and 2 by 5 and 2, and once you press the generate button, you will get 4 images. And here you can see this fruit looks like a hybrid of mango and strawberry. And additionally, on the left side, you can see how many generations you're left with in your freemium model. So here we can see we have used 3 out of 5 free generations that we give to every new user. This is the example of video generation. I've saved these videos and I can play it for you. So the first video is an aeroplane swimming in water. So this is how the generated video looks. And this video shows a dancing mosquito. So both these videos were generated by the Genius AI platform. Now coming on to the next modality, we have code generation. So here you can see I gave the prompt that I want a C++ code for in-order traversal. So I got this prompt and I can copy this and use it wherever I want. Now coming on to music generation, we can see I'll just play this audio, and the prompt that was given was audio of a solo guitar. I hope you were able to hear this. Now coming on to the last modality that we have is normal conversations. So here you can simply give any prompt. So I just gave the prompt, what is the radius of the sun? And we got this response, the radius of sun is this. So all these 5 modalities are available on a single platform, Genius AI, and all these modalities could be accessed through this left side interface. Now coming on to the results and impact, our platform has achieved significant results across multiple dimensions. Technically, we have successfully integrated 5 different content modalities into a cohesive system. The platform has proven stable and production ready. And more importantly, we have achieved our core goal, which was making advanced AI accessible to non-technical users. We have seen adoption across education, where teachers create learning materials, media production, where creators build multimedia content, and software development, where developers accelerate prototyping. The system demonstrates sophisticated language understanding and also consistently produces high quality outputs. Like any other platform, we also have some limitations. Some regions face payment gateway restrictions, and we are dependent on external API providers, which introduces latency and cost considerations. As we scale, the database optimizations will be crucial. However, we have an exciting roadmap ahead. We're exploring localized AI models to reduce external dependencies and also improve the performance. Collaborative features will enable team-based content creation, and we're also investigating AR/VR integration with immersive experiences. And future versions will give user more control over model selection and parameters. And these enhancements will position Genius AI as a truly comprehensive enterprise-ready platform. And finally, to conclude, Genius AI represents a significant step forward in making generative AI accessible and practical. We have successfully unified 5 content modalities into a single user-friendly platform, addressing the key pain point of fragmentation in current Gen AI ecosystem. While lowering the technical barriers, we are democratizing access to advanced AI capabilities for people like educators, creators, and developers. And our platform establishes a new benchmark for usability and integrations in the multi-modal AI tools. And we believe this work opens exciting possibilities for how people create and interact with digital content. Thank you.
Thank
I'm
you for
open to
the
any questions.
presentation. Ma'am, do you have any questions?
Yes, I do have. Hi, Prabjot. I have a
Hello,
one
ma'am.
question.
Yeah.
Like the concept is really good. It is combining three, four AI tools together.
Yes.
My question is, after successful implementation of this and the deployment of this project, is it available in open source for all the users?
Yes, ma'am. It is available. So here you can see this is the GitHub repository link, and the code is fully available. And we have not currently deployed it because all the APIs that we are using, they are paid ones, and like this is not a paid project, and we don't have funds for the credits now. So, but the code is openly available, and anyone who wants to use this, they can simply deploy it or also use it locally, and they can use their own API keys.
Okay. Concept is really good. Yeah.
Thank
Thank
you.
you.
Thank you.
Good presentation and good concept.
Thank you. Thank you, ma'am.
So next we have Vijendra, paper titled IoT and Knowledge Management in Smart Cities, Advancement in Collaborative and Real-Time Knowledge System. Vijendra, are you there? Vijendra, are you there? Okay. So next we have Pawan, paper titled Portable Real-Time Sign Language Mediator with Embedded Machine Learning.
Hello.
You may please start presenting your screen.
Okay. I hope my screen is visible now.
Yes, you may start.
So, good afternoon, everyone. I am Pavanas, and today I will be presenting our work titled Portable Real-Time Sign Language Mediator with Embedded Machine Learning. So, our research focuses on building an affordable, portable, and real-time sign language translation system using embedded TinyML. So, a significant number of deaf and hard of hearing individuals face challenges in daily communication due to the lack of accessible interpretation tools. So, human interpreters are also limited in availability, and most existing smart glove solutions are either expensive or depend on cloud connectivity and external computing devices. Such requirements reduce mobility, compromises privacy, and makes the solution unsuitable for low resource or connectivity limited environments. So this motivated us to explore whether machine learning based gesture recognition can be performed directly on low powered embedded hardware without relying on the cloud. So our motivation is to design an inclusive assistive technology that empowers individuals with speech and hearing impairments by executing machine learning tasks locally on microcontroller. We aim to ensure privacy, affordability, reliability, and independence, especially for users in low resource settings. Now, coming to the objectives, the key objectives of our works are as follows. So, to develop a lightweight and comfortable wearable system suitable for long-term use. And the second one is to implement TinyML directly on an ESP32 microcontroller, enabling local gesture processing without internet dependency. And then to evaluate whether accurate and low latency gesture classification is feasible under embedded constraints. And finally, to provide a synchronized text and speech output through a locally hosted web interface accessing from common devices. So our main contributions include a smart glove-based system using an ESP32 to recognize hand gestures and transmit results via Wi-Fi, and an intentional sensor minimization using only a single flex sensor and one gyroscope to study low-cost feasibility, and deployment of an optimized random forest classifier for an on-device TinyML inference, and fully offline operation with no requirement for cloud connectivity, and a locally hosted Flask web server that displays text at outputs and provides audio feedback. So this slide illustrates our system architecture. So the sensor data from the flex sensor and the MPU6050 gyroscope is collected by the ESP32, and the embedded random forest model performs the real-time gesture classification directly on the microcontroller, and the predicted output is sent to a local web server, which provides text display through a web interface and audio output through text-to-speech. This architecture ensures low latency, privacy, and portability. So here we show a physical prototype of the smart glove. The ESP32 and the sensors are mounted in a compact and wearable form factor. Special attention was given to the comfort, stability, and minimal wiring, ensuring that the system is practical for real-world usage. So coming in terms of the hardware, the system consists of a ESP32 microcontroller with a built-in Wi-Fi, an MPU6050 gyroscope for identifying the wrist orientations, a single flex sensor for finger bending detection, and on the software side, machine learning models were trained using Python and scikit-learn, and embedded code was developed using Arduino IDE, and a Flask web server handles the visualizations and audio outputs. So this slide summarizes the performance metrics of the random forest classifier, including the accuracy, precision, recall, and reference score. So our proposed system achieved a high classification performance with an accuracy of approximately 99.32 and a consistent reference score. And also the total latency were between 150 to 200 millisecond, making the system suitable for real-time interaction. And despite operating on constrained hardware, the model is memory efficient and also energy efficient, enabling long-term usage. Now coming to the limitations. Starting with the limitation, the current system supports a small vocabulary of only 5 static gestures, which was intentional to choose because it was to evaluate the feasibility on constrained embedded hardware. Additionally, the data set was collected from a single participant, which may limit the generalization across different users. And we also observed some occasional confusions between gestures with similar wrist orientation, particularly due to reduced number of sensors used. And moving to the future works, we plan to expand the gesture vocabulary to over 25 signs to make the system more practical for real-world communication. We also aim to incorporate additional sensor data such as accelerometer readings and more flex sensors to improve the robustness and reduce ambiguity. Further, we intend to explore quantized TinyML-based CNN models to support continuous and dynamic sign recognition, as well as multilingual output to increase global usability. And to conclude, this work demonstrate that efficient TinyML models, specifically random forest classifiers, can achieve high accuracy on resource-constrained device like ESP32, and the proposed system provides a standalone real-time and multimodal sign language translation solution, effectively bridging the communication gap and promoting inclusive accessibility. So these were the references that we used, and that's it with my presentation. So any questions?
Thank you for the presentation. Ma'am, do you have any questions?
Yes, I do have. Hi. How much is the costing for this prototype?
The sensors that we used were flex sensors and gyroscope, which were very cheap, under 500 only. So We used only these two sensors, so it was a little cheap.
No, like if the person is trying to use it, it should be cheaper one, then only they are going to buy it. And second thing is that can you collect more data set for the flexibility of your module, because it is a really a good concept and it is helpful for the people. So, but the right data set will give you the right output. So
Yeah,
currently
yeah.
the data
Currently,
set.
we have only used 5 gestures. This was specifically because we were trying to find out the feasibility of our project. So we were trying to make a model that was more feasible. So in future, we'll be trying to implement more. Yes, it is possible to include more gestures. And since it has greatly worked on these 5 gestures because it has great accuracy on that random forest model, we'll be able to add more gestures and possibly give more accuracy.
Even you can use the videos and the data sets that are available. You can also train the model based on that, so that
Yeah,
it
that
will
can be
give.
also used.
Yeah. Have you checked about any data sets related to?
No, currently I have only image data set. I've worked on image data set, but I haven't done on videos.
Yeah,
So
you might get many videos regarding it. You can even feed to your system and train the model with it will give you a better accuracy and the results as well.
yes,
That's it from my side. Thank you.
thank you for the feedback.
Yes, Shaswat, any more presentations?
Yes, ma'am. Yes, ma'am. Now we have Deepa, paper titled Influence of AI-Enabled E-Governance on Sustainable HR Practice, a field-based study.
Good afternoon, everyone. This is Deepa Verma. I'm
You may
sharing
please
my
start
yeah.
with your presentation.
yeah. Is my screen visible?
Yes, it is.
Okay. So my title is The Influence of AI-Enabled E-Governance on Sustainable HR Practices, a field-based study. Introduction. Digital transformation has reshaped governance and HR functions. AI and e-governance improve transparency, accountability, and efficiency. Sustainable HR practices require ethical, data-driven decision systems, and integration of AI with governance framework supports ESG objectives. Now, the background of the study: e-governance standardizes HR processes and improves auditability. AI reduces bias in recruitment, performance appraisals, and learning systems. Digital HR platforms reduce resource waste and environmental footprint. Sustainable HR emerges from combined AI adoption and governance strength. Now, the problem statement: traditional HR systems lacks transparency and scalability, and weak governance in AI adoption may reduce employee trust. Limited empirical evidence on AI-enabled e-governance and sustainable HR, and there is need to quantify the impact of digital governance mechanism. The objectives of the study are to examine the influence of AI-enabled systems on sustainable HR practices, to assess the role of e-governance adoption in HR sustainability, to analyze the combined impact of AI and governance mechanisms, to empirically validate the proposed model using field study data. Now, these are the literature review. According to the author Dylan and Yamin, their focus area AI in recruitment. Key insight in this paper was AI improves objectivity and efficiency, and the major findings are it enhances recruitment and performance transparency. Malik at 2023, his focus area was AI HR ecosystem, and his key insight was employee engagement improves sustainability. And major findings, it strengthens compliance and accountability. Revol, his focus area was trust in AI, HR tools, and his key insight was fairness mediates acceptance. And the major findings are digital HR reduces waste and improves inclusivity. Smith, according to Smith et al., AI in civil service, his key insight was governance enhances adoption and AI governance yields long-term results. Now the research design and the methodology. The nature of the study, it was empirical and quantitative. Research design, cross-sectional survey, and the data type was the primary data. And respondents in this study were employees and HR professionals. We took a sample size of 280 respondents, and the research tools we used were descriptive statistic, correlation analysis, regression analysis, ANOVA, and diagnostic residual analysis. The variables in the study, independent variables, e-governance adoption, AI-enabled selection, AI-driven performance management, and dependent variables, sustainable HR practices. The key result of this study, regression model explains nearly 66% variance in sustainable HR practices. ANOVA confirms overall model significance. AI-enabled selection and AI-driven performance management show strong effects. E-governance supports HR sustainability through institutional structure. Major findings. AI adoption significantly improves sustainable HR outcomes. Digital performance management enhances fairness and efficiency. Governance mechanisms strengthen consistency and compliance. Integrated AI governance system outperform isolated digital initiatives. Conclusion. AI-enabled e-governance forms a robust foundation for sustainable HRM. Sustainability in HR is achieved through systematic digital integration. Governance ensures ethical deployment of AI in HR functions. Empirical evidence validates the proposed conceptual framework. And the implication of the study in the managerial firm, adoption of AI-driven HR system improves long-term efficiency. Its policy should need strong governance frameworks in AI deployment, and in academic, it extends literature in AI governance and sustainability. Practical, it supports ESG aligned HR decision making. The scope for the future study, comparative study across industries and countries, inclusion of mediating or moderating variables, longitudinal analysis of AI HR sustainability outcomes. So this is the presentation. Thank you.
Thank you for the presentation. Ma'am, do you have any questions?
Yeah, I have. What is the use of this AI HR sustainability?
Please pardon, ma'am.
What is the use of this AI HR sustainability?
AI HR sustainability. Ma'am, these days in the organization, when AI is dominant in every area, we need AI HR sustainability because it like it increases the sustainable practices which we are using in the organization. And when we use AI, it supports that system. So this is a use. And it is used in sustainable recruitment and selection. And AI screens resumes, and it makes the work easy. It eliminates all the biases and what like biases in the gender, age, or the background. So all these are the uses of this AI in HR. It is easing the work.
Have you implemented any prototype, or it is just a conceptualized work based on the surveys?
And this is a practical, in every organization now, AI is being used in this for the screen resuming, for the selection, recruitment, in every areas for the HR practices.
Yeah, it has been already using in many, not even in India, in many countries, in many organizations, because AI is nowadays it is playing a very important role in everyone's lives. But I'm not getting the sustainability work. Means it is already there. Means what's new in your concept?
Ma'am, new. It is like we are studying whatever is being like studied, and we are finding the new ways which in AI will support this all the recruitment things and the all the HR processes.
That's it from my side.
Thank you, ma'am.
So next we have Gia, paper title Therapeutics Leveraging Artificial Intelligence for Secure and Complement Soap Note Automation.
Hello, is my screen visible?
Yes, it is.
So, good afternoon, everyone. Myself, Chia Bera, and today I will be presenting my paper titled Therapeutics Leveraging AI for Secure and Compliant Soap Note Automation. This work is co-authored by Hers Subhashna and Nisha Cheta. In this presentation, I will briefly talk about the problem we identified in clinical documentation, how we approached it using AI, and what outcomes we achieved. Here is a quick overview of what I will be covering today.
Sorry to disturb you, Jia. Please put your PPTs in presentation mode.
Is it now, ma'am?
Yes. Thank you.
Sorry for that. So, with recent advancements in AI and NLP, healthcare automation has grown significantly. However, one area that still remains quite manual is clinical documentation, especially SOAP notes, which stands for Subjective Objective Assessment and Plan. Writing these notes manually takes a lot of time, increases the chances of errors, and often reduces the time clinicians can spend with patients. So, to address this, we propose Therapeutics, which automates SOAP note generation using AI while maintaining accuracy and data security. The motivation behind this work comes from the real challenges faced by physiotherapists and allied health professionals. So, clinical documentation is essential, but it's also extremely time consuming. Manual SOAP note creation leads to increased administrative workload, fatigue, and inconsistency in records. When clinicians spend more time documenting, they naturally spend less time interacting with patients, which affects overall care quality. With advancements in speech recognition and NLP, we saw an opportunity to automate this process in a secure and reliable way, which led to the development of Therapeutics. Based on this motive, we defined few key objectives. We aim to build an AI-powered web platform that can automatically generate SOAP notes from recorded therapy sessions. We also wanted to ensure accurate clinical information extraction using speech to text and NLP techniques. Another important goal was reducing the administrative burden on clients, clinicians, while maintaining high accuracy, consistency, and up to the standard of healthcare. We reviewed existing research on AI-based clinical documentation, speech recognition in healthcare, and electronic health record summarization. While prior studies show promising results, many systems still struggle with clinical context understanding, security, and practical deployment. These gaps helped us guide the decision of our system. Currently, most clinicians rely on manuals of documentation or, let's say, template based systems. Some tools use speech to text, like EHR, but they simply convert voice into text without understanding clinical meaning. EHR systems mainly focus on storage rather than intelligent automation. As a result, these approaches are time consuming, quite error prone, and lack real time AI driven summarization. Now, coming to our methodology, first, a therapy session. Yes. First, therapy sessions are recorded during the consultation. The audio is then transcribed using AI based speech recognition. Next, NLP techniques extract clinically relevant information such as subjective complaints, objective findings, assessments, and treatment plans. LLM models then structure this information into proper SOAP notes, which are reviewed and finalized by clinicians before secure storage or exports. So this is the implementation. Here is the sign up page. Once the clinician sign up, he is redirected to this module. And here they can add the patient, as I hope you can see over here. And they can start recording the conversation between the clinician and patient. Once that is recorded and submitted, this is the UI that they are given, and here is the notes that they can take. Such as first is the initial note, and they can take the follow-up notes for that. Once you click on the initial note or any of the note, this is the area, and in that subjective, objective, and the data they can get. The results were quite encouraging. The system successfully generated structured and accurate SOAP notes from therapy session recordings. We observed a noticeable reduction in documentation time along with improved consistency. The slide shows the comparative analysis of our system. For speech to text, we evaluated word error rate, which ranged between 8 to 12%, and character error rate showed acceptable accuracy for medical terms. For clinical information extraction, we measured precision recall F1 score across the SOAP components. The results remain consistently high and indicating accurate and reliable extraction. Overall, these results confirm that Therapix performs well in both transcription and clinical summarization. To conclude, Therapix demonstrates how AI and NLP can be effectively used to automate clinical documentation. The system generates accurate and structured SOAP notes, reduces administrative workload, and while ensuring secure data handling. Overall, it helps improve clinical workflow efficiency as well as documentation quality. Looking ahead, there are several possible extensions to this work. We plan to integrate emotion and sentiment analysis to better understand patient interactions. Support for multiple languages and wearable device data can further enrich clinical insights. We also see a strong potential in combining AI with human expertise. This slide lists the key research papers and resources that supported our work. With that, I would like to conclude my presentation. Thank you for your time, and I would be happy to answer any questions.
Thank you for the presentation. Ma'am, do you have any questions?
Yes, I do have. Hi, Jia.
Hello.
Have you collected any real-time data set for this project?
We have used OpenAI only.
Okay. How you have taken the data set then?
Data set is not taken, but we have used OpenAI and the research papers that I showed to you. And the system was evaluated using simulated therapy session recordings and sample clinical conversations. We manually created the clinical conversation for the approach and privacy.
Okay. No, because it's the clinical data, right? So it is not available easily. We need to take a proper permission. If the hospitals are ready, then only they are providing.
Yes, we have taken the consent before, but right now I can't disclose that.
Okay, all right. Thank you.
Thank you.
So next we have Vijendra, paper titled Transforming Supply Chains for Sustainability, Harnessing IoT and AI to Overcome Challenges and Seize Green Opportunities. Vijendra, are you there? Vijendra, are you there? I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of our whole team, thank you for the support during the 10th version and all previous 9 versions of the conference. We will be happy to have you in 11th version in 2027. All the presenters would be getting their digital certificates through mail within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SMARTCOM 2026. I also thanks our session chair, Dr. Rashmi Kale, for chairing this session. A token of appreciation to the chair on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Ma'am, would you like to share a quick closing remark with us?
Hi. Hello, everyone. It's been really nice to attend this conference on live online platform. Everyone has shared the new trends and innovative ideas over here, and all the ideas are really good. I really appreciate from the bottom of my heart to every participant for presenting such a nice ideas and the knowledge that I have also get from it and the innovations that we are getting. And thank you for participating and presenting your work. And it's really been a nice session. Thank you, Shashwat, as well. It's been a nice anchoring and introduction. Yeah, thank you all.
Uh, I kindly request all to switch on the cameras for a quick snapshot of a virtual conference. Guys, please switch on the cameras. Okay, thank you. Stay safe. Have a nice day.
Thank you all.